This is 2020 AMC 10A problem number 5. What is the sum of all real numbers x for which the absolute value of x squared over 12x, x squared minus 12x plus 34 is equal to 2? A, 12, B, 15, C, 18, and D, 21, and E, 25. So we can split this problem up into two cases. So case one is that the left-hand side of the problem is equal to 2, which means we can just completely get rid of the absolute value since it changes nothing. So we have x squared minus 12x plus 34 is equal to 2. Simplifying, we get x squared minus 12x plus 32 is equal to 0. Now before we move on, let's get our second equation from our second case. So we have case 2. And in case 2, we have that x squared minus 12x plus 34 is equal to negative 2. But this will still mean that this equation here is still valid because it's giving the absolute value, which means negative 2 will be turned into 2. So we have x squared minus 12x plus 34 is equal to negative 2. Simplifying, we have x squared minus 12x plus 36 is equal to 0. Now, we can see that it wants us to find the sum of all real numbers x. So here, instead of factoring and factoring is tedious and stuff, we can simply use Vietta's formula. And if you don't know, Vietta's formula states that if you have a quadratic in the form ax squared plus bx plus c is equal to 0, then it says that the sum of roots of this quadratic are equal to negative b over a. So here we have b equals minus 12 right here, right there. We have b equals minus 12 right there. And we have a is equal to 1 since there is no coefficient on the x squared. So we have the sum of roots is negative 12 over 1, which is just 12. Now we can move on to case 2, but we have to be careful here because this expression turns out to be a perfect square trinomial. And you can see that because it's in the form of x squared minus 2ab technically minus 2bx plus b squared, where b is 6. So we can factor this into x minus 6 squared equals 0, so x equals 6. So even though the sum of the roots of this expression here, even though the sum of the roots is 12, it's just 6 repeated twice, which means we would be overcounting since we counted 6 twice, and it just wants us to find the sum of real numbers. So we have 12 from case 1 plus 6 from case 2, which gives us a final answer of 18. And that is answer choice C.